Cooking requires proper attention to measurements. Successful cooking depends on following the recipe. Too much or too little of an ingredient greatly affects the taste and outcome of the food being prepared. Measurement is important, of course, not only in controlling the portion size of the recipe, but also in estimating the total cost when cooking. So for this week class, we will be dealing with carrying out measurements and calculations in a required task. Selecting the proper measuring tool and closely following the measurements stated in the recipe are both important. It is also vital to have sufficient knowledge of measurement conversion from one kitchen unit to another. For our objectives class, okay, to carry out measurements and calculations in a required task, to calculate cost of production, and to measure ingredients according to recipe requirement. The metric system is a weighing standard that is used in most countries. Traditional measures in the imperial and US standard vary in their quantities. Cups, pints, quarts, and gallons mean different things in different countries. The metric system is a system of measurement that uses the meter, liter, and gram as base units of length, for the distance, capacity, the volume, and weight, the mass respectively. It is also important to note that metric recipes specify the quantity of many ingredients by weight instead of volume, and that fractions are seldom used with the metric system. So we have here the table of the prefixes in the metric system. So I hope that you are all familiar with the metric system as we had discussed it during our first reading. So let's have a short review. As the base units class, we have the meter, gram, and the liter. Okay, so let's have them one by one. Let's start with kilo. So kilo, which means it is 1,000 times larger than base unit. Hecto, which means it has 100 times larger than base unit. Deca, which means it is 10 times larger than base unit. We also have the deci, which means it is 10 times smaller than the base unit. We also have the centi, which means that it has 100 times smaller than base unit. And for the last one, we have the milli. Okay? We have 1,000 times smaller than base unit. Combining the three basic units for length, of course we have meter, weight, of course gram, and volume, liter, with the prefixes create table of units that is used in cooking. Okay, so for the first one, for the first column, we have the symbol. Second column, we have the quantity. Third column, we have the uses. Okay, so let's start with milliliter. Okay, so we have here the milliliter, which is intended for smaller volume. Okay, so it is used for measuring most liquids not used very often or non-liquids. We also have the liter. Okay? Liter, of course, is intended for large volume. Take note of this class, ha? Smaller volume, large volume, smaller weights, and of course, large weights. Okay, so we have the liter again. It is intended for large volume for measuring large amount of liquids or the volume of pots, okay, mixing bowls. Okay. Liters are not used for measuring dry ingredients. Okay. We also have the gram. Okay, it is intended for smaller weights. Okay, for measuring the majority of non-liquid ingredients, including flour, sugar, cheese, butter. Okay. We also have the last one, which is kilogram. Kilogram is intended for large weights, okay? For measuring quantities of non-liquid ingredients, including meats, fruits, and vegetables. Class, kindly take note of this conversion table liquid or spoon measurement. Okay, so we have here, okay, for the first column, we have the American, okay, system of measurement. For the second column, we have the imperial system of measurement. And for the third column, we have the metric system of measurement. Okay, so 2 tablespoons or 1 ounce force, which is equivalent to 1 fluid ounce, is equivalent to 28 ml. Okay, take note of the following. We have the 1/4 cup, of course, which is equivalent to 2 ounces. Okay, equivalent glass to 2 fluid ounces. And for the metric system, we have 56 milliliters. Okay? We also have 1/3 cup or 2.5 ounces, which is equivalent, of course, to 2.5 fluid ounces. Okay? For the metric system, it is equivalent to 75 milliliters. We also have 1/2 cup, okay, or 4 ounces. Okay, which is equivalent to 4 fluid ounces. Okay, and for the metric system, 4 fluid ounces is equivalent to 110 ml. We also have 2/3 cups or 5 ounces. Okay, for imperial, it is equivalent to 5 fluid ounces. Okay, and for the metric system of measurement, it is equivalent to 150 milliliters. We also have 3/4 cups or 6 ounce, okay, which is equivalent, okay, to 6 fluid ounces. Okay. Also, class, in metric system, it is, of course, equivalent to 170 milliliters. For the last one, we have 1 cup. Okay, take note of this, 1 cup, which is equivalent to 8 fluid ounces and equivalent to 225 milliliters. Let's proceed, class, to, of course, the weights. Okay, so we have the US or UK system of measurement. Of course, we have the metric system of measurement. Okay, for 1 ounce, it is equivalent to 28.350 grams. Again, 1 ounce is equivalent to 28.350 grams. 2 ounces, we have 56.7 grams. 4 ounces, okay, we have 113.4 grams. Okay, 4 ounces rather is also equivalent to 1/4 pounds. Okay, we also have the 5 ounces, okay, which is equivalent, of course, to 1/3 pounds. Okay, equivalent, class, to 141.7 grams. We also have 6 ounces, okay, which is equivalent to 170.1 grams. We have 7 ounces, which is equivalent to 198.4 grams. 8 ounces, okay, which is equivalent also to 1/2 pounds. Okay, so we have 226.8 grams. Okay, we also have 10 ounces, which is equivalent to 283.5 grams. Of course, 12 ounces, okay, which is equivalent to 3.4 pounds. Okay, we have 340.2 grams. Okay, we also have 14 ounces, which is equivalent to 0.9 grams. Okay, we also have 16 ounces, okay, which is equivalent to 453.6 grams. And for the last one, okay, we have 1 kilogram, which is equivalent, of course, class, to 2.2 pounds. Temperature measurements are used especially when recipe calls for cooking in an oven, gas range, or fan-assisted gas oven. So cooking time and temperatures vary, of course, depending on the type of equipment the recipe calls for, and of course, the equipment available. Okay, so to convert, for example, Celsius into Fahrenheit, okay, we'll just multiply the given temperature by 1.8, then add 32. Okay, for Fahrenheit to Celsius, of course, deduct 32, then multiply the result by 1.8. Okay, so let's proceed to the following example. So, how many Fahrenheit are there in 100 degrees Celsius? Okay, so we are going to multiply 100, of course, by 1.8, then we are going to add 32. Okay, so the answer will be 212 degrees Fahrenheit. How about, okay, from degree Fahrenheit to Celsius? Okay, so we have the given 200 degrees, okay, minus 32 divided by 1.8, okay, so we have the answer, which is 93.3 degrees Celsius. So let's try, class. So give the equivalent measure of the following. Okay, the first one, we have cup to liters. Okay, how many liters are there in 1 cup? Number 2, how many, okay, tablespoons are there in 28 ml? Okay, number 3, we have ounces to grams. Okay, so how many grams are there in 16 ounces? And for the last one, how many Fahrenheit, of course, are there in 200 degrees Celsius? Okay, so have the computation, okay, in your notebook. Let's check, class, okay, your answers. Okay, for number 1, you have cup to liters. Okay, so again, how many liters are there in 1 cup? Okay, so take note of this, class. If 1 cup is equivalent to 225 milliliters, okay, remember that, class, okay, milliliters has, of course, 1,000, or is 1,000 smaller than, okay, the base unit, which is, of course, the liters. Meaning, class, 1 cup is equals to 0.225 liters. Okay, based, of course, on our table, how many, okay, tablespoons are there in 28 ml? So the answer is, of course, there are 2 tablespoons, of course, in 28 ml. Okay, we also have ounces to grams. Okay, so how many grams are there in 16 ounces? Okay, so we have 453.6 grams. Okay, again, the following, of course, is given on our table of weights. Okay, we also have, okay, 1 pound is equivalent to 16 ounces. Okay, we also have degree Celsius to Fahrenheit. Okay, so how many, okay, Fahrenheit are there in 200 degrees Celsius? Okay, so we are going to multiply 200, of course, by 1.8, and we are going to add 32, which gives us the answer, 392 degrees Fahrenheit. At times, class, a recipe will call for a quantity that is not a standard measurement, such as pinch, dash, jigger, scan, or heaping. Okay? Measurements, of course, of this type can be confusing as the exact quantity to use. So we will be dealing, of course, class, with the miscellaneous measures. Okay? Okay, so first one, we have pinch. Okay, pinch, of course, is a measurement, of course, used on dry ingredients. That is the amount. Okay, you can pinch between your forefinger and thumb. So it is less than a dash and equivalent to approximately 1/16 teaspoon. We also have the dash. Okay, so the dash is a small amount of an ingredient equivalent to over 1/16 teaspoon but less than 1/8 teaspoon when measuring dry ingredients. A dash used to measure liquid ingredients equals, of course, approximately 3 drops. Okay, we also have the jigger. Okay, so the jigger is a measurement equivalent to 3 tablespoons or 1.5 fluid ounces. Okay, we have the scan. So the scan indicates that you should use slightly less than the actual measure. Okay? And for the last one, we have heaping. Okay, so heaping is a term used when measuring, of course, dry ingredients, indicating that enough ingredients should be added in the measure so that it heaps over the rim of the measuring cup or spoon. Okay, so here is, of course, our illustration. Class, let's move on to the measuring tips. Okay, so kindly take a look at this. Okay, so tip number 1. You may accidentally tip the measuring device or overpour the ingredients, and excess ingredients would fall into the mixture. So of course, this could ruin the whole batch depending on the ingredient and how much was spilled. Okay, so measure over the sink, another bowl, or a sheet of wax paper to catch any excess spillage. Okay, so spillage caught on wax paper can be returned to the ingredients container. If you do not have 2 sets of measuring cups or spoons that can be used separately for the dry and liquid ingredients, measure the dry ingredients first, of course, before using the measuring cups and spoons for the liquid ingredients. Okay, so you are going to store loose dry ingredients such as salt in a lidded container. So the ingredient, of course, can then be spooned out and leveled rather than trying to pour it into a measuring spoon and having it spill over the edges. Of course, to help you keep track of which ingredients you have measured and added in the mixing bowl, place all the ingredients on one side of the mixing bowl, and once you have measured and add ingredients, move its container to the opposite side of the bowl. For our last tip, of course, when cooking, class, learn to estimate all the small measurements of ingredients, of course, to save time. So pour measure the amount of an ingredient into the palm of your hand. So observe the look and feel of the quantity and then try to pour that same amount into your palm without measuring first. So measure the amount you pour out to see, of course, how close you are to the actual measure. Let's proceed, class, to the cost of production. Okay, so this week, class, of course, we are going to calculate the markup percentage. So I have here, of course, okay, the table for the total cost, okay, of a recipe called, of course, hot cake. Okay, so for the first column, we have the quantity. Second column, we have the ingredients. Third column, we have the unit price, and of course, the cost. So as you can see, class, okay, for our unit price, okay, we are going to multiply, of course, the unit price to, yes, to the quantity, okay, that is needed, of course, for a certain recipe. Okay, so for example, we have here 8 pesos. Okay, 8 pesos, of course, times 4 cups. Okay, we we got 32 pesos. So the same thing, of course, same formula follows. For example, we have 8 pesos per teaspoon and you'll be needing 1/4 teaspoon. Okay, 5 pesos per egg and you'll be needing 2 pieces only. Okay, so that's how we are going to calculate the cost of production. And of course, you are going to add the cost, okay, of each ingredients. So we derive, okay, our answer, of course, through the basic mathematical operation. Okay, class. So say you were able to make 10 hot cakes. Okay? So using this table, class, you can find the food cost by dividing, of course, the total cost incurred in preparing the recipe by the number of yields. Okay, so meaning, okay, again, we have the number of yields. We have the 10 hot cakes. Okay, so meaning 57, of course, divided by 10. Okay, we got 5.70 per hot cake. Okay, so that's the food cost. So, any person working in business or retail will find the skill of being able to calculate markup percentage very valuable. Again, class, our food cost from the earlier table, of course, we have 5.70. Okay, for this lesson class, we are going first to define markup. So markup is the difference between how much an item costs you and how much you sell that item for your profit per item. So that's the markup. Okay. So for the first one, we are going to calculate your peso markup. So of course, this is done by subtracting your buying price from your selling price. Okay. So the selling price of hot cake per piece is 10 pesos. Okay. So the food cost, okay, we have 5.70. And of course, we are going to subtract, okay, our buying price from your selling price. So 10 pesos minus 5.70. So we come up with the answer for 130 pesos. Okay, so that's our peso markup. Decide, of course, whether you want to calculate your percentage markup based on cost or selling price. Okay? Because this is a little bit different. So once you choose which you will be using to calculate, it is important to stick to the method you choose throughout all your calculations, or you will end up with faulty data. For example, if you decide to calculate your percent markup based on cost, then we will proceed to step 3. But if you decide to calculate your percentage markup based on selling price, we will go on to step 4. Okay? So, okay, here's our step 3. So, calculate percent markup based on cost. So this is done, of course, by dividing the peso markup by the cost. Again, we have the peso markup, which is 4.30 pesos. Okay? So we are going to divide. Okay? Divide the peso markup by the cost. So 5.70, okay, we have the purchase cost or buying price. Okay? So meaning, class, 4.30 divided by 5.70, of course, we come up with 75%. Okay? Next, we are going to calculate your percent markup based on selling price. So this is done, of course, by dividing the peso markup by the selling price. So for example, we have the peso markup, which is 4.30, and the selling price is 10 pesos. So what are we going to do? Okay, we are going to divide 4.30, of course, by 10 pesos. And we'll get the percentage markup, which is 43%. Okay, so make sure, class, that you consistently use either cost of the product or selling price to find the percent markup of an item. Even though the cost, okay, selling price and peso markup will always be the same, the percentage markup will be drastically different depending, of course, on if you calculate it using selling price or cost. So, using selling price will give you, of course, a lower percentage markup, assuming class that you are making a profit now, okay? So, while using cost will give you, of course, a higher percentage markup, okay? So, you're going to answer page 49, compute for percentage markup, and your assignment will be how do you apply what you learned, okay? So thanks class. Do you have any questions? So feel free to send me a message. Goodbye and thank you.